All right, good morning, everyone. I will continue to say good morning until 6 p.m. today. This is a talk about an open source universal router, not only for power line communications, but for also for USB and for other devices that can be connected to the network. And let me introduce Florian, who is a student of telecommunications engineering, I think. Yes. And Xavier is the chief technical officer of Open Pattern, which is a French company. So there's a warm welcome for you. Let's have an applause for the people here.
Thank you. Thank you. Everybody can hear me? Yeah. So first, it's a great pleasure to be here and be able to speak out in front of this crowd, as it was. I was on your side in the previous CCC, so it's a great pleasure to present something. So we have 45 minutes to discuss one tool that we've been developing since a year about what we call PLC, which stands for Power Line Communications. The idea behind power line communications is to use the electrical cables to set up logical network. And so far there was no real open source tool that can be used to configure or to try to do extensive features like we will see. So why FIFA is a long story. I will make it short. FIFA means electricity in Lao language. Laos is a small country of 4 million people located between Vietnam and China and Thailand and Cambodia. And basically in Lao languages, you don't have very modern terms. So when you want to make a technical term, you have to add words together. So for electricity, you have to add fire and light. So the logo of the tool is basically FIFA written in Lao language. So the outline of the presentation, first I will do a small 101 class of what is power line communications for those who are not familiar with this technology. It's basically located at the physical and MAC layer. We will see a little bit of security issues, and then we will target one specific standard, which is called HomePlug AV, which is the latest power line communication standard, industrial standard. As we speak, last week, there is an IEEE group which works on the standardization of this technology, and they have been voting different baseline for the future draft of the standard. And on last Thursday, they've been voting for this HomePlug AV technology to be the baseline for the next generation of standard for IEEE. So the name of the standard will be IEEE 1901. And because they are using HomePlug AV for the draft, we are pretty confident that the tool we have been developing for HomePlug AV will be able to be ported and used for the next IEEE standard coming in 2009. Then we will go more in details about the hardware parts and what are the features of the FIFA tool. And a little bit of a demo with some equipment that we brought that you can find out there in the market. So, like I said, power line communications is the usage of electrical cables for logical area network. Could be on the public electrical network, could be on the private electrical network. Basically, you can split applications in two main groups, outdoor and indoor. In the outdoor applications world, the idea is to provide internet access over electrical cables from the core electrical network to the very end user after the electrical meter that you have at home. And you have the so-called private electrical network, the one that you can find after the meter, after the electrical meter, and that covers the electrical network for a home or a building, hotel, hospital, and so on. If we make an equivalent between what we have in networking, you can imagine the electrical cable environment like a big hub at the layer 2, and basically you will have the plug on one side and the RJ45 on the other side. If you plug that all over the electrical network, you will have basically a big hub where the media is splitted and shared between all the tools and devices connected on the electrical network. Just a little bit of history. Like I started my talk, now IEEE is doing a standardization of this technology. So far, there were no real IEEE standards, so there were a fight in the markets between different technology. In light, you have what we call high bitrate technology. This technology are using the 1 to 30 megahertz frequency band, this part. And in light gray, you have some low bitrate power line. I'm sorry for the quality of the schematic. And the low bitrate is using this band, which is the 3 to 150 kilohertz, which holds less space for bandwidth and bitrates. So we will target high bitrates. That's the one used for logical IR network. And like I said, the standard coming up is called IEEE 1901. Basically, IEEE is going from 1 to 802, and then they continue with different technology. And for power line, it's the 1901 group. So the standard will be called 1901. I'm lacking one schematic, I don't know why. Basically, the idea was to show you the two main applications that I was talking about, outdoor and indoor. So indoor, basically, you have the green signal going from electrical plug to electrical plug. One question that we have often is, do I have the signal going outside of my house or my electrical network? Basically, it depends on the meter, but for most countries, the meter is not blocking the signal. So you will find the PLC signal from your neighbor or from next door going to your electrical network, and there is no real blocking of the frequency that I was talking about. So if I go a little bit more in details about the physical and MAC layer, at the physical layer, they are using OFDM, orthogonal frequency division multiplexing. That's the one technology that we can find in most network technology like DSL, Wi-Fi 802.11g, WiMAX, and so on. And there is an adaptive coding depending on the quality of the channel. So they will switch from the best quality of modulation and coding with 1024 QAM, which is quite high, low to PSK for more robust transmission. If you do the math at 1024 QAM, you can go up to 200 megabits per second at the physical layer. At the MAC layer, you will find CSMA, so you will find a medium which is not able to give you collision detection, so you will have to implement collision avoidance, and the rest will be quasi similar to 802.3 IEEE frames. So basically what is doing OFDM is splitting the binary stream between different subbands and transmitting the subbands from one part of the electrical network to the other part. If you have perturbation between these bands, they will not block the whole bands because OFDM is very strong to be only perturbated by one subbands. More visually, we've been doing tried of sniffing PLC communications. So as you can imagine, the cable is behaving like an antenna. Especially electrical cable are basically straight going in each rooms, each part of buildings. So you will have some emissions, radio emissions outside of the cable. If you make a test at 1 meter with a signal analyzer and you try to use 60 kHz per division, you will find in the 1 to 30 megahertz DOFDM modulation. So this is 1, this is 30 megahertz. You will see basically the physical layer, and you will have the adaptive modulation changing all the time when the channel is changing, basically when some electrical plugs, electrical devices are changing the quality of the channel. So this is what we find at the physical layer using a signal analyzer. Now in real, in the market you can find many types of PLC equipment. You will find Ethernet bridges for PLC line, basically that kind of tool where you have like the electrical plug, could be European or Japanese or American, and you can find the Ethernet ports. On the same idea, you will find different devices like set-top boxes. For instance, in France, we are very fond of set-top boxes for DSL access. So now all the ISP in France are using PLC for local area network between devices of the offer they have. You will see MCU gateways, some equipment that you can put at the head of the electrical network for a building, and from that you can spread the signal over the building. In the US you will find something called sling boxes, where you can take the video cast stream and resend that stream over either a local network or a remote network. Some IP video cameras are using PLC now. A device called Y-Power, basically it's like an electrical charger, except that he has two cables, the electrical cable going to feed the devices and the network cable going to the boxes. And you have some ISP devices also. I think the main change will be that IEEE now, by choosing one technology, will make more confidence into the chip market, and the people in the chip market will develop chips that they will embed in some devices. I am pretty confident that in some year we will have, like we have Wi-Fi chips inside laptops, we will have PLC chips inside laptops. And you will be able just to plug your laptop and get the feed from the electrical network from power line signal. So like I said, we are basically stacking the classical physical and MAC layer. So you will find the physical data units embedding the MAC layer data units and then transmitting that over the cable. So if we look at the security issues in power line communications, the first one, compared to Wi-Fi, is the difficult access to the medium. Wi-Fi is radio, so anyone is able to basically sniff the radio, either in promiscuous mode or active mode. In the power line communications, if you want to sniff, you need a complete set of tools to have from the logic analyzer to the analog to digital converter, demodulator, then you need to dump the data and you need to decrypt that data. So it's not easy like you can find a chip card and just dump the data and do the decrypting offline. Plus, at the physical layer, like I said, every 5 seconds you have reconfiguration of the modulation. So if you are sniffing, if you want to sniff the whole